Alright, what's going on, guys? In this video we're going to be looking at the time taken in seconds for a satellite to complete an orbit around the Earth using the formula of periodic time, which we will write out right now. Okay, so I'm going to clear off this. We were changing the subject of a formula in our last video. So now in this one we've got an excellent question to test you. So it'll be, here is the formula that we'll be using. So we have t is equal to the square root of 4 pi squared or cubed over gm. Okay, where or is the radius of rotation from the center of the Earth, g is the universal gravitational constant. So g is the universal gravitational constant. I'm going to get blue. M is mass of the Earth, and the or is the radius of rotation from the center of the Earth. Okay, so now question 1, we want to express this equation in terms of or. Okay, so now first what we want to do is we'll square it to get rid of the square root. So we'd have t squared is equal to 4 pi squared or cubed. So we're after getting rid of the square root by squaring both sides. And now we'll multiply across by gm. T squared by gm. To get rid of the gm as a fraction, so we'd have 4 pi squared or squared. And now we want or on its own, so we divide by 4 pi squared. So t squared for gm, we divide both sides by 4 pi squared. Pi squared is equal to or squared. Okay, now I'll get red. Okay, so we want the square root of this to get or on its own, so or would be equal to the square root of t squared by gm over 4 pi squared. Very good. So that's it in terms of or. That's the first question done. Now on to the second part. So the International Space Station, the ISS, orbits the Earth once every 91 minutes. So 91 minutes. Okay. Given that the value for g is equal to 6.67 multiplied by 10 minus 11. So g equal to 6.67 multiplied by 10 to the minus 11. So that's the gravitational constant. And the mass of the Earth, so m, the mass of the Earth, is equal to 6.4. So this is the actual mass of the Earth that we live on, which is pretty cool to know. So this is how much it weighs, 10 to the 24. That's a huge number. Find the radius of rotation of the ISS correct to the nearest meter. Okay, so we want to find the radius correct to the near meter, and first we want to change 91 minutes into seconds. So 91 multiplied by 60 equal to, so we're going to get our trusty calculator now. Go through this. Alright, so sorry for the noise. I'll get my calculator out and I'll put it in. 91 by 60. 91 multiplied by 60, which is equal to 5,460 seconds. 5,460 seconds. Alright. So now we'll just sub these into the formula. So or is equal to square root of 5,460 squared by g. G is 6.67 multiplied by 10 to the minus 11 by m, which is 6.4 multiplied by 10 to the 24. Okay. Multiplied by 6.4 by 10 to the 24. And all of that will be over 4 pi squared. So now I'm just going to get these values by subbing it into my calculator. And when you sub all of that in, and you go through it, what you will get is ore is equal to the cubed root Oh, I see. So up here we actually have the cubed root, so it wasn't ore squared. So you want to get the cubed root of this to get ore on its own. So this was originally 3 up there, so this is the same thing, so we just get the cubed root of that. So the cubed root of ore, or the cube root of this, would equal to ore, and that is 3.224 multiplied by 10 to the power of 20. So ore is equal to 6,856,625.858 equal to ore. That's what ore is. So that is ore equal to 6,856,625 meters. Nice. So now for part 3. Part 3 is find the height that the ISS is above the surface of the Earth given that the radius of the Earth is 6,371 kilometers. Give your answer to the nearest kilometer. Okay, so the height of the Earth is equal to 6,371 kilometers, which is equal to 6371000 meters. Alright, so now we'll just subtract this 637 from 6856. So 6856625 minus 6371000. If you put that into your calculator, you will get 485,626, and that is equal to the height above Earth of the satellite. Okay, thus the ISS is at a height of 485,626 meters, which is equal to 486 km above the surface of the Earth. That's where the ISS is. Earth's surface. Alright, cool. So thank you for watching. Great job on getting through this, guys. See, can you pause it and go back to the start? Just do the questions out yourself. And just definitely follow along and try to do the maths as well so you can learn better. And I will see you in the next video. We'll have more exciting exam questions to be doing. And good luck. Alright guys, so this is the next video on our course of algebra and covering some fundamental concepts in maths. So in the last one we were doing a fun exam question of the rotation of the ISS space station around the Earth. So you can check that out in the previous video, and in this one we're going to be having a look at unknown coefficients and how to solve these problems. So undetermined coefficients, so we'll do that now. Clear? So our first question will be x squared minus 6x plus t is equal to x plus k squared. Okay, so x squared minus 6x, we're going to multiply it out on the right side, is equal to x squared plus 2kx plus k squared. Alright, so now we want to equate the coefficients. So first we'll do x squared. So x squared is equal to x squared. Right. Then we'd have minus 6x and 2kx. So minus 6x is equal to 2kx. So I want to get k, so we'd have divided by x's, we can divide them across by the x, so minus 6 is equal to 2k, so we divided both sides by x, so k would be equal to minus 3. Alright, did you get that? So we divided by 2 there, and then minus 6 divided by 2 is 3, so k is equal to minus 3. Now we'd sub this in to our other one. Shut the fuck up. Okay. So in this one, we'll be doing equating the k's. So t is equal to k is equal to k squared. So t is equal to, from here, minus 3 squared. So t is equal to 9. Alright, so that's our other one, and that's the problem solved. So we have, therefore, k is equal to minus 3, t is equal to 9. Nice one. So now let's go on to the next question. Actually, we'll leave the next question for the next video, where we'll be doing a more advanced version of this. So I thank you for watching. See, can you do it on your own now by working your way through it? Great job. Be sure to practice your maths, and I will see you in the next video, guys. Alright guys, so in the last video we were looking at undetermined coefficients. In this one we will be doing a more advanced question on that. So let's jump right into it. I'll write it out now. It's quite a long question. Okay, so these are some fundamental math skills in manipulating algebra and working with algebra, which you should be very comfortable with in general, because it's such a fundamental thing in maths. So we're in a nice orange color, a y squared. You're going to have plus, this is a plus by, y minus 4, plus c by y minus 4 is equal to 4, or is equal to y squared. I'm going to rub that out. Y squared plus 13y minus 20. Okay, so we're going to multiply it out first. Plus by squared, so by by y is by squared, by by minus 4 would be minus 4by, multiply out the c, so plus cy, then c by minus 4 is minus 4c, and this is equal to y squared plus 13y minus 20. Alright, I'm going to switch up the colours, keep it interesting. Now we need to equate the like terms. So we're going to have the terms containing y squared first. So this would be here, terms containing y squared. So we have ay squared plus by squared is equal to y squared, right? So we can just factor out the y squared, so a plus b is equal to 1. So we just divide it by the y squared. That'll be our 1, so that'll be our first one. Now for the next few terms, I'll change the colour, so for with the 1y, terms containing 1y, we have minus 4b cy 13y, so we'd have minus 4by plus cy is equal to 13y. Okay, so what we do is we divide by y, so minus 4b plus c is equal to 13, and that'll be our second one. So now we have the ones independent of y. So the terms independent of y, we'd have minus 20 and minus 4c. So minus 4c is equal to minus 20. C is equal to 5. Okay. And now we can work backwards from there. So we can sub c is equal to 5 into our second one. So minus 4b plus 5 is equal to 13. So that's from here. So we'd have minus 4b is equal to, take 5 and it'll be minus 5, so we get 8. Minus 4b, so 8 divided by minus 4b would be equal to minus 2. Okay. So that's, now we have b, so now we can sub it into our first one, which is our one up here. So a plus b is equal to 1. We know what a, we don't know what a is yet, so a plus minus 2 is equal to 1. So a would be equal to 3. And there you go. So therefore, a is equal to 3, b is equal to minus 2, and c is equal to 5. So did you get that, guys? How we did it, we equated the like terms. So up here we have ay squared. We equated the y squared terms. And then we removed the y squared. So up here you can see my red. We got a plus b is equal to 1, and that was our first one. Then we equated the ones with y on its own. So we had these, minus 4by plus cy, 13y, and then we just let them equal. We got rid of the y's. We had minus 4b plus c is equal to 13. And then for the third one, we had the ones with no y's, which is minus 4c minus 20. So minus 4c minus 20. We got c is equal to 5, and now we work backwards from there, subbing them into each one. So I thank you for watching, guys, and I will see you in the next one. Good luck, keep going, you're doing great. And the next one will have some surds, which are fun and quite confusing as well. So it should be a good challenge. So I'll see you in that one. Alright guys, so in this episode we're going to be looking at surds and surd equations. So let's jump right into it. I'm going to write out some fundamental rules, and in the last one we were looking at undetermined coefficients using our algebra skills. So now let's go on to surds. So I'll write down our heading. We have surds. Okay, so properties of surds. The first rule is AB is equal to A, then by square root of B. So square root of AB is equal to square root of A by square root of B. Second rule is square root of a over b is equal to square root of a over the square root of b. Okay, third rule is square root of a by square root of a is equal to a. Alright, so you can change color now and we'll do some examples. So just something to note here, the simplification of surds, when you're simplifying them, you find the largest possible perfect square number greater than 1 that will divide evenly into the number under the square root, then use this property ab equal to the square root of a square root of b. And that's when you're simplifying surds. So let's show you now. So we have square root of 99, right? So this would equal to the square root of 9, but it's 11. So we'd get square root of 9 is 3, and then we'd have the square root of 11. So that'll be our first one. Alright, good job. Now the second one, it'd be half, then by square root of 112. Okay. So this would equal to a half square root of 16 by 7 is equal to a half of square root of 16 by the square root of 7. So if we bring that down here to your left, this would be half of 4 by the square root of 7. So this would equal to 2 by the square root of 7. Alright, nice. So now the third one, change color again. We have the square root of oh whoops, we didn't need to write something before that. So we'd have this square root of 2 by 1 over 4. Now let's see what happens here. So this would equal to square root of 9 over 4, because when we add the 2 to the 1 over 4, we'd get the 8, and then we add that to the 1 and we get the 9 over 4. This would equal to square root of 9 over the square root of 4, which if you look down to our right, that would equal to 3 over 2. Alright, very good. And you can use your Casio or your calculator to verify. So you just sub in the square roots, like all these different, just sub that in your calculator, you'll get 3 square root of 11. Sub this in your calculator, you'd get 2 square root of 7. And same with 2 multiplied by 1/4. You get 3 over 2. Alright, nice, good job. Okay, so we'll do some more. So now, express each of the following in its simplest surd form, okay? So the square root of 180 plus square root of 20 minus the square root of 125, and we want to express them in its simplest surd form. Okay, so the square root of 180, well, for that we'd have 36 multiplied by 5, square root of 36 multiplied by 5, plus the square root of 4 multiplied by 5, then minus square root of 25 by the square root of 5. Okay, so that would be square root of 36 by the square root of 5 plus square root of 4 by the square root of 5 minus square root of 25 by the square root of 5. Alright, we can just simplify them down now. So that would be 6 by the square root of 5 plus 2 by the square root of 5 minus 5 by the square root of 5. And these are all like terms, so we can just add them as is. So we'll bring these up here. Alright. So that would be 8 minus 5, which would be 3 square root of 5 would be our answer then. Alright, very good. So good job on getting through that, guys. In the next one we'll be looking at rationalizing the denominator. And so a quick note on this, a key point is addition and subtraction. Only like surds, so like only like surds, square root of 5, you can see these are like surds. Only like surds can be added or subtracted. Express each surd in its simplest form and add or subtract like surds. Okay, so thanks for watching, and I will see you in the next video. You're doing great. Keep going with the course. You'll be there in no time. So thanks for watching. Alright guys, so in this video we're going to be looking at rationalizing the denominator with surd equations. So let's get right into it. So in the last video we were doing the rules of surds and how to simplify them. So we're doing more in depth on that now. Let's go. So heading, rationalizing the denominator. Okay. So see, can you stick through to the end of this video? We got some good questions in this for you. Okay, so this is the general rule. So let's say that x over plus square root of b. How you get rid of that is you multiply by the conjugate, which would be minus square root of b over a minus square root of b. And that's the general rule for this. Now let's show you some examples. So let's say we wanted to express 1 over 3 square root of 5 minus 1 over 2 square root of 20 in the form k square root of 5, okay? So how we do that is we do 1 by 3 square root of 5 minus 1 over 2 by square root of 4 by the square root of 5. That'll be 1 by 3 square root of 5 minus 1 over 2 by 2 square root of 5. So that would be 1 over 3 square root of 5 minus 1 over 4 square root of 5. Okay, nice. So now you want to move them up. So we add the fractions. So we're going to move this up here. We'll do 1 over 3 square root of 5 minus 1 over 4 square root of 5. Then we'd have 4 minus 3 over 12 square root of 5 because we multiplied them. Here we cross multiplied, or we multiplied each of them to get the common denominator, and now we're going to multiply this. After we do it, we'll have 1/12 square root of 5. Now we want to multiply by the conjugate. I want to multiply by the bottom by its surd over square root of 5. So that would be square root of 5 over 12 by 5. So this would equal to the square root of 5 over 60. So this would be equal to 160 by the square root of 5. Nice. Alright, so to rationalize the denominator, you multiply the top and bottom by the surd. And that's what we did. So you can see here we multiply the top and the bottom by the surd. The top and bottom, we multiply them by the surd. And that's how we rationalize it. Okay, and rationalize means getting rid of the surd in the fraction. So now in the next question we have 1 minus square root of 3 over 1 plus square root of 3. We want to write it in the form a square root of 3 minus b, where a and b are elements of n. So multiply the top and the bottom by the conjugate of the bottom. Okay, so we'll see what that means now. So we'll have 1 minus square root of 3 over 1 plus square root of 3 multiplied by 1 minus square root of 3, because that's the conjugate of the bottom, over 1 minus square root of 3. Okay, so we can change colour. So that would be, if we multiply each of them, we'd have 1, then minus square root of 3, and we'd have minus square root of 3. So multiplying this by that, and then we'd have plus 3. I'm going to do the same for the bottom. So 1 by 1 is 1. 1 by minus square root of 3 would be minus square root of 3. Square root of 3 by 1 would be plus square root of 3. And square root of 3 by minus square root of 3 would be minus 3. So these two would cancel out. So we have 1 minus 2 square root of 3 plus 3 over 1 minus 3, which would be minus 2. Okay. So now what's next? Well, we'd have 4 minus 2. 4 minus 2 square root of 3 from here. 1 plus 3. Be 4 square root of 3 over minus 2. And now what we need to do is we need to factor out the minus 2 and then divide, okay? So we'll do that now. We're just going to rub out this other stuff to the left so we'll have room. Okay, just rubbing it out. Alright. Alright, now we should have some good room. Okay. So my paintbrush back, I'm going to use the blue, right? It's the light blue. So we factor out minus 2, and then we'd have minus 2 plus square root of 3 over minus 2, and the minus 2's will cancel out, so this will give us minus 2 plus square root of 3. Alright, very good. And that's the answer to that. So that proves that it can be written in the form as we set up here, a to the square root of 3 minus b, so it can be written as square root of 3 minus b, or a square root of 3 minus b. So that would be a is equal to 1 and b would be equal to 2. So thanks for watching, guys, and I will see you in the next one. Great job in getting through this video. Sorry if it was a bit confusing. Be sure to go through it again, and we have plenty more videos explaining these topics and other videos to build you up to this level if you need it. And yeah, thanks for watching. Alright guys, so in this video we're going to be solving some quadratic and cubic equations. Okay, so let's go and edit this and just remove, we'll clear. So let's get right into it. So quadratic equations are in the form ax squared plus bx plus c is equal to 0. Okay, so now we'll have some example questions. So we'll have 3x squared minus 5x minus 12 is equal to 0. And there's two ways you can solve a quadratic equation. So the first way, by let each factor equal to 0, so let each factor equal to 0, okay? Second way is you can use the formula, the quadratic formula. And the quadratic formula looks like this. So you'd have x is equal to minus b plus or minus b squared minus 4ac all over 2a, alright? That's the quadratic formula. So now let's solve this question we have up here. So our guide number is when we multiply this by our constant. So this would be minus 36 is our guide number. So what two numbers would add together out of this to give us minus 5? Well, those would be 3x plus 4, and we'd have x minus 3 is equal to 0. So that's when we have it factorized, and we find that out. So you know how to factorize these by now, because we have many videos on it, but you can watch. So be sure to check them out in the course. Alright, so let's carry on with it. So now we let 3x plus 4 equal to 0. And we let x minus 3 equal to 0, and then we'd solve for x. So we have 3x equal to minus 4, then x is equal to minus 4 over 3. Okay, so that's 1x. Then we have x is equal to 3 on this side. Okay, so now that's that one solved. So we have our two values for x, and that's what should happen with a quadratic. Now our second one will be a bit harder. So we'll be using the formula in this one. Okay, so we'd have 2x squared minus 7x plus 4 equal to 0. Right. So now we can't actually find any factors for this. So when we get a guide number, we'd get 8, and we can't find them that add together to give us minus 7. So we'd use our quadratic formula. So we'd use the formula up here, x equal to minus b. So in this case, our a would be 2, our b would be minus 7, and our c would be 4. So a would be 2, b would be equal to minus 7, and our c would be equal to 4, as you can see from up here. And that's in that form on our top left. That's how that works, where you get the numbers from. Okay, so now let's just sub them in. So we'd have x is equal to minus, sub them in with brackets, remember, so you don't get mixed up. So plus or minus square root b squared, which would be minus 7 squared, minus 4 by 2 by 4, all over 2 by 2, right? So x is equal to, this would be 7 plus or minus square root of 49 minus 32 all over 4, right? So this would be equal again to 7 plus or minus all this over 4 square root of 17. So then we'd have two answers. So x can either equal to 7 plus square root of 17 over 4, or x can equal to 7 minus square root of 17 over 4. Right, so there's the solution to them two. I thank you for watching, and I will see you in the next one. Good job, guys, you're doing great. We'll have a great question in the next video. So good luck.
going on? Dinner. So I was thinking to take the dogs for a walk after dinner then, and then we could possibly call in for this thing. But with your schedule and commitments. Dinner, Donald. Did you get any of that? Wasn't there any kind of alcohol subject? Well, no, I don't think I'm not saying that. I'm just saying you should be able to come with me. Drop in and have a look at it. Sure. So we spoke for a walk with walk around the Argymore with the dogs with me after dinner and then go to his place and then figure it out and then come back home, yeah, no, yeah. Okay. If all you people come down and have a dinner please, thank you.
Ba 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 ba. Alright guys, so this is another lesson on your course on algebra. This is the subject of quadratic and cubic equations. Okay, so we have an excellent question today, so I'll write it down straight out and then we'll work through it. So I'm going to clear what we have up from our last lesson and now let's fly through this. So we have a triangle, okay, with three sides as triangles have, -1. This is the right, so this side opposite would be the hypotenuse. Just keep in mind, just because we're going to be using that. So there's a bit of geometry will come into this one. So this is on quadratics and cubic equations. Okay, so these are our three sides. So the lengths of the side of a right angle triangle are given by the expressions x minus 1, which we have here, 4x, which you have here, and 5x minus 9. So as shown in the diagram, find the value of x. Okay, so we know this is the hypotenuse, so using Pythagoras' theorem, we know that 5x minus 9 squared is equal to the other two sides squared, so that's x minus 1 squared plus 4x squared, okay? So we'd work through that, so we'd have 25x squared by minus 90x plus 81, because 9 squared is 81, that is equal to x squared plus or minus 2x plus 1 plus 16x squared. Okay, so if we move 16x squared over to the left side, we'd get 9x squared. If we move the minus 2x over to the other side, we'd get minus 88x. And if we move the plus 1 over to the other side, that'll give us minus 1, so that'll be plus 80 equal to x squared, and we'll move the x squared over to the other side as well. So that would subtract 1x squared from 9x squared, that'll be 8x squared minus 88x plus 80, and you can see we can factor out the 8 here. You can take out an 8, that'll be x squared minus 11x plus 10 is equal to 0. Alright, so minus 10 by minus 1 would give us plus 10, and then minus 10 minus 1 would give us minus 11, so that would work as a factor. So x minus 10, x minus 1. Okay, so two answers we have is x equal to 10 and x equal to 1. And we'd have to cross out this because x can't equal to 1, because up here we have x minus 1, and therefore we'd have one side that's equal to 0, which wouldn't make any sense because sides can't be equal to 0 on a triangle, because then it wouldn't work because there'd be no length on it. Okay, so we have x equal to 10 as our answer. And now the step 2 is verify with this value of x that the lengths of the sides of the triangle above form a Pythagorean triple. So you want to prove that it forms a Pythagorean triple. Pythagorean triple. Alright, so we'll sub in the values. So we have 5 by 10 minus 9, and we'd have all that squared. So that would be 41. That'd be whoopsie daisies, what's going on here? Sorry about that, guys. Well, we seem to have moved a bit for whatever reason. We're gonna fit the view. Okay, we can zoom in now. Whoopsie daisies. Alright, guys. We just have to keep working ahead. Things seem to have glitched there, but anyway, so this 5 to 10 minus 9, that'll be 41 squared, and we'll just keep subbing in the values. So then x minus 1, that'll be 9 squared, then plus 4 by 10, which would be 40 squared. Okay, so this would be 41 squared equal to 81 plus 1600. So this would be 1681 is equal to 81 plus 1600, and 1681 equal to 1681. That is correct. So therefore it is a Pythagorean triple. So that was an excellent question. Good job if you got through it. Sorry about that little glitch there with the software. And I will see you in the next one, guys. So you're doing a great job. Keep working through. We're almost through our second chapter now of these lessons on the course. So good luck and stay tuned. Alright guys, so in this episode we're going to be working through some more of our Zero to Mastery web development course. So I'm going to open up my VS Code editor here on our left, which I have to say VS Code is the best code editor. Comment down below if you agree or not. Let's see what we get. Now we're going to have building our React app episode 3. So we're using state in this, and you'll see what I mean. We're using JavaScript and state. Okay, so here's our component that we were building in the last video. We're going to skip through and we're going to be building it out as we go. So we're editing our app.js and we're going to add in all our files and create some new components, okay? So app.js is now going to be our home base for this episode, okay? So we're going to remove all of this because we don't need it anymore, and we're going to change the app around. Okay, we don't need to import app.css, so we're going to import two others. So we'll have import search box, which we're going to create shortly from /search box. Okay, that's one. And we're going to import robots, which is a robots array that we're building, from /robots. Okay, so now we'll have a constant app is equal to a function which returns a div here. Okay, so we'll have a div to return all one element, but in this div we'll have h1 of RoboFriends, and we'll have our search box component. So we're going to be rendering out each of our components. Box. We're going to make that self-closing, guys. So just want to have our slash there. We're going to have a card list, and we'll pass robots to it, so robots equal to destructuring robots props. And we want to make that self-closing as well. Okay. So we're going to edit our search box for one-way data flow. So we're going to be adding state shortly to our app by creating a state variable and making it a class to store state. Alright, so let's make our app so that it stores state. So how we do that is we change this syntax to a class called app that extends component, and then we'll have a constructor in here. Constructor and within this we call super, and we'll have this dot state equal to robots, and then with value of robots, and search field with empty string. So we'll do on search change event console.log event, and now we're going to do a render function which will wrap all this inside of. So we'll have render and curly braces, and we'll move this all up a line. Okay, we'll pull down alt, and there we go. Now it's inside our render. Alright, very good. Now we've added state, so we'll create some more. So we're going to create our search box component, search box.js, and we're going to import React from React. So that's common. Now we're going to have a const of search box equal to, we're going to be passing it down to props of search field and search change. Okay, and we're going to be giving it the arrows for a div tag with an input. I'm going to make the input a self-closing tag. Alright, this is self-closing tag, so we can add some stuff now. We'll have class name JSX syntax, which is equal to, we'll add some tachyons now. PA3 BA B dash dash green and BG lightest blue. Okay. And you'll see what this all does in a moment. Building out this app. Okay, so now I'm gonna go up. I'm gonna have a type equal to search, and we'll have a placeholder of equal to search robots. Okay, and we're going to export that now. Export default search box. Okay, so we're also going to have on change. So on any change, we'll have that equal to search change. So it'll run search change then. Okay, and that's once again showing one-way data flow. So in our app, we're going to create more on the onSearchChange function. Have app.js onSearchChange event. Console log will do event.target.value. We're going to be passing props to search box by doing search change equal to this dot on search change, and we'll have a card list with robots equal to this dot state dot robots, because it's a class now. So we need to call this dot state, and we have this dot state defined up in our constructor function here with the super. Okay, so now let's add more to our onSearchChange function. We have a const of filtered robots is equal to this dot state dot robots dot filter. So we'll give it robots, and it will return curly braces return robots dot name dot to lower case parentheses dot includes, and we'll give it search field dot to lower case. Okay. And now we're gonna actually give it, set this wrap this part in curly braces and set search field's value in the constructor to event.target.value for our input. Alright. So now if we also, with our div, if we just add the class name of TC for text center and tachyons. So we have our class app extends robots search field empty. So we'll be filling up our search field and going through filtered robots. So what we're doing here with the code is we're importing our search box component, we're importing React, and we're importing our robots array, all our robots objects. So we have class app extends components, so this has state because it's a class. So now we're running constructor to give it state, and we have this.state equal to robots, which gives it the value of robots from where we got robots up here, destructuring the array. Then we have search field, which is empty, and then on search change event, so the event there, console.log search field.event.target.value. So it changed the search field value to event.target.value, whatever the event is. So then we have a const, we're creating a variable here, const filtered robots. We have this.state.robots.filter, so it's getting from robots up here, whatever the robots are, and it's going through them. For each of them, it's filtering through the robots. It's getting the input of robots, and then it's return robots.name to lowercase. It's returning robots.name to lowercase, all the text to lowercase. Dot includes search field dot to lowercase. So we have the search field there and all that to lowercase, and we have the search field value here that we'd be inputting. Okay, so then we have our render function here to render out the app, and we return a div with a class name of TC to put it at the center. And we have a h1 of RoboFriends for our title. We have a search box with search change props. We're giving it this.onSearchChange, so that's something we're passing down to search box. Then card list, we're passing down robots to that, and it has this.state.robots, and we get robots from here. Okay, so we're passing down the props of robots to the card list, and we're passing down search change function to search box. Okay, so now let's have a look at search box. So search box is here. You can see we have our search box, search field, search change. Okay, so now we're gonna have another look back over the code, make sure everything's spick and span. Alright, good stuff, we're doing well. So I'll see you in the next video, guys. Thanks for watching. Comment down below what projects you're making in React, and good luck. Alright guys, so in this video we're going to be styling our React app. So let's get on it. We'll have tachyons. So we have our code here. our app.js and we want to add some niceness to it. We're going to go to index.css. We have our body here and we can make some nice edits to that, giving it a cool background. Alright, so we can add the Sega Wolf font as well. Okay. So we can have, we'll get a nice gradient background on it. Okay. CSS gradient background, right? We can click on that, search it up. Yeah, go on, we'll take that one. That looks nice. So we can copy this from here, we can just paste it into our body. And now for the H1 we'll make some nice Sega logo text. And how we do that is we add font family of, you need to download the Sega logo font before you can do this though, so just search it up on Google and it'll come up, download, and then we'd have font weight 200. Okay. Oh, sorry, this is CSS, so I need to use semicolons. So then we'd have font weight, and then we'd have color of hashtag 0CCAC4. Make it nice and blue. Okay. And now we need to import the Sega Wolf font. Sega.wolf. Okay, so we can open. Actually, if we just will open it there. Alright, open. We'll open it in Notepad. So we'll just copy all of that. Control C, and we'll create a new file here. And we'll call it Sega.wolf. Alright. And we'll just paste all that code in here. So we just paste all that code in there. And now, right, so that's how you style your app. So with the Sega logo font, I will need to be importing that now. And once you're finished, you've imported app.css and your app.js. So we're going to import app.css. Okay. Nice, so that's that. And when you're done, it should look like this. Really nice looking, okay? And you can maneuver around this app as well. So, thanks for watching, and I will see you in the next one. Good luck.